Welcome to Math with Mrs. Bibb. Today I will be reviewing how to solve absolute value equations and inequalities. First, let's talk about conjunctions. When you have absolute value problems, you will have conjunctions. In mathematics, we use the conjunctions and or. If you have absolute value and an equal sign, so a problem that has absolute value and an equal sign, that conjunction is or. If you have absolute value and this inequality symbol, absolute value and this inequality symbol, all of these have the conjunction or. If you have absolute value and a less than symbol or a less than or equal to symbol, then the conjunction is and. And is the intersection of the shading, and or is the union of the shading. And I'll describe more about that when I review how to graph inequalities. And here is interval notation and number lines. So I want us to remember how to graph inequality answers on a number line. Okay. If I have x is greater than 5, x is less than or equal to negative 2, x is greater than or equal to 2. To graph on a number line, first thing I want you to do is draw a number line. I want you to remember that if you have greater than or less than, these are open circles. And if you have greater than or equal to, less than or equal to, these are closed circles. And you should be writing all that down. Okay, so greater than is here. So that means on 5 on the number line, and I'll just put 5 there. I don't make my number line really fancy. On 5, I'm going to put an open circle. And where are the numbers greater than 5? Are they greater than 5 to the right or greater than 5 to the left of 5? Well, here's a test you can do. Is 6 greater than 5? Yes. Is 7 greater than 5? Yes. So then I shade to the right. And that's my shading for x is greater than 5. X is less than negative 2, less than or equal to, negative 2. So I'm going to put negative 2 on my number line. It is less than or equal to, so that's a closed circle that I'm going to put on negative 2. Closed circle. Okay, where are the numbers less than or equal to negative 2? So if I go to the right, this is negative 1. Is negative 1 less than or equal to negative 2? No, it's greater than. So then that means I shade to the left, less than or equal to. The next one, draw a number line. Greater than or equal to 2. So greater than or equal to is a closed circle. Closed circle. Greater than or equal to. Shades to the right. Now I want to talk about putting this in interval notation. Interval notation is the concept here that you need for Algebra 2. Interval notation, when you have open circles, you use parentheses. Also, when you have infinity, or negative infinity, then you use parentheses. Closed circles will get brackets. And you read your number line from left to right. From left to right. left to right. And please write this on your paper. This is negative infinity to positive infinity. Negative infinity to positive infinity. So we're going to read that number line from left to right. So here's my number line, here's the left side, here's the right side. So reading my black number line from left to right, where does the black number line start being read? Well, it's not read over here at negative infinity. It starts being read at 5. So I'm going to write down the number 5. Oops. I can't make up my mind, can I? We'll write down the number 5, and it's an open circle at 5. Open circles get parentheses, so open at 5, and then the shading continues forever to infinity. So 5 to infinity. And infinity also gets a parenthesis, so that's interval notation for that problem. Okay, the next one. I'm going to read my number line from left to right. And this number line was originally black. Where does this number line start being shaded red? Negative infinity. Where does it stop being shaded red? Negative 2. So let's write that. From negative infinity with the parenthesis to negative 2, and negative 2 is solid or closed, so then that means I have to use a bracket. That's my interval notation for that second example. And then the last example, reading this number line from left to right. Where does this black number line start being shaded red? Is it red over here at negative infinity? No. It starts at positive 2 with a closed circle, so I'm going to use a bracket, and it stops at infinity. So we said it starts at positive 2 with a closed circle, and it stops at infinity. Okay. The compound inequalities will get a little bit trickier, but I'll show you how to do those when we get there. Sorry about that. Let me erase my little mark. Absolute value equations. Here's the steps that you follow. Make sure your absolute value is alone. Let me go through all these examples and use a highlighter. You want this to be alone. You want this to be alone. You want this to be alone. And I'll highlight the ones on the next slide in just a moment. If you notice, all of mine are alone. So I'm good there. Next it says check the constant on the right. Check this number on the right once you have it alone. Make sure it's a positive. If it's a positive, then continue. If it's a negative, then write no solution. So it's a positive, so we're good. Then we're solving absolute value equations. It says write 2 equations with the word or in the middle. So let me tell you about those 2 equations. So I'm going to put the word or in the middle. Okay, so I'm going to write 2 equations. You take what's in the absolute value out, set it equal to positive 9, or take what's in the absolute value out, set it equal to negative 9, and solve both of those, and both of those are your answers. So to solve this, I know you all know that you divide by 3. To solve this one, also divide by 3. So my solutions, here's my nice solution set. These are braces, and you just put them in order from least to greatest, are negative 3 and positive 3. Those are the solutions to number 1. Number 2, take what's in the absolute value out, b divided by 5, set it equal to positive 1, or take what's in the absolute value out, b divided by 5 equals negative 1. So you set it equal to a positive and equal to a negative, and then solve. How do I get rid of dividing by 5? I multiply by 5. So b equals 1 times 5 is 5. Or, how do I get rid of dividing by 5? Multiply by 5. So the 5's cancel out. B equals negative 5. So my solutions are negative 5, positive 5, in order from least to greatest. So the next one, take what's in the absolute value out. Don't ever change it. Negative 2r minus 1 equals 11. Or take this out again. Don't change it. Negative 2r minus 1 equals negative 11. And then solve both of those. Add 1. Negative 2r equals 12. Divide by negative 2. R equals negative 6. Or add 1. Negative 2r equals negative 10. Divide by negative 2. R equals positive 5. So my two solutions are, sorry, that one looks bad, negative 6, positive 5. Okay, now let's go to the next examples. And again, I'm going to highlight because the first thing we want to do is to make sure the absolute value is alone. And look, that one is not alone over there. You have a minus 5 with it. And here, oh, look at this. This one's not alone. It has more than one thing. It has a multiply by 3 and a minus 3 with it. So I got to get rid of those green things. This one has a multiply by 5 and a subtract 7 with it. So I got to get that away from it before I can actually solve. And then this absolute value has adding 5 and a subtracting 8. Sorry, no, multiplying by negative 8. Oops, see, that's, students do that too. That's one that a lot of students will miss. So be very careful. That's the first thing I'm going to do is I'm going to go through and get all these alone. How do I get rid of subtracting 5? I add 5. So I've got the absolute value of b plus 8 equals 7. Okay, here I've got two things to get rid of. Do I get rid of multiplying by 3 first or subtracting 3? And hopefully you said get rid of subtracting 3 first. So 3 times the absolute value of 3 minus 5r equals 21. Now I have to divide by 3. So the absolute value of 3 minus 5r equals 7. Now the absolute value is alone. So number 6, I'm going to add 7 first. 5 times the absolute value of 9 minus 5n equals 45. I'm going to divide by 5. The absolute value of 9 minus 5n equals 9. And now my absolute value is alone. Next, over here, students will want to put these together first, but that's not what we do. We have to get rid of the adding 5 first by subtracting 5. So negative 8 times the absolute value of negative 2n equals negative 80. Divide by negative 8. The absolute value of negative 2n equals positive 10. Now, the next thing says check this number on the right. Once your absolute value is alone, which all of these are alone, check your number on the right. It has to be a positive. All of these are, so I'm good. None of those are no solution. But if any of these were a negative number, then you would write no solution under here and you'd be finished. But they're unfortunately not. Any of them are negative. So now we have to write our two equations with the word or in the middle. So take what's in the absolute value out, set it equal to positive 7, or take what's in the absolute value out, set it equal to negative 7, and solve. You get b alone by subtracting 8, so b is negative 1, or you get b alone by subtracting 8, b is negative 15. So my two answers are negative 15 and negative 1 for number 4. For number 5, write the word or. 3 minus 5r equals 7, so take what's in the absolute value out, set it equal to positive 7, or take what's in the absolute value out of it, set it equal to negative 7. Solve by subtracting 3 first. Negative 5r equals 4. Divide by negative 5. R equals negative 4/5. For the second one, subtract 3. Negative 5r equals negative 10. Divide by negative 5. R equals positive 2. So my two solutions are negative 4/5 and positive 2. That's the answer to number 5. Number 6, put the word or down. take what's in the absolute value out, 9 minus 5 in, set it equal to positive 9, or take what's in the absolute value out, 9 minus 5 in, set it equal to negative 9. Subtract 9 from both sides, negative 5 in equals 0, divide by negative 5, n equals 0. Subtract 9, negative 5n equals negative 18, divide by negative 5, n equals positive 18 over 5. So my two solutions are positive 18 over 5 and 0. And I did not put those in order from smallest to largest, but that's okay. It isn't always smallest to largest. That's usually the habit I try to get into, but I messed that one up, and I don't want to erase, so we'll just leave it like that. Okay, for the next one, write the word or. Negative 2n equals positive 10, or negative 2n equals negative 10. Divide both sides by negative 2. N equals negative 5. Divide both sides by negative 2. N equals positive 5. So my two solutions for this last one are negative 5 and positive 5. Okay, so that's how you solve an absolute value equation. Now we'll move on to inequalities. It says equation versus inequality. So an equation has an equal sign. An inequality has one of these symbols, greater than or equal to, less than or equal to. So I want you to remember equations are equals, those are always or. That's your conjunction. For inequalities, this symbol and, this symbol, they're side by side. And this symbol each have different conjunctions when you're working with absolute value. It has to be absolute value and an equation, or absolute value and an inequality. So if you have absolute value and one of these symbols, then my conjunction is or. If you have absolute value in one of these symbols, my conjunction is and. Here is a silly way that I remember this. Greater than, or equal to. And I promise as I write this, I do know how to spell. Great or than. Greater than is equal to. Greater than is or. Greater than is or. So remember, I spelled it wrong on purpose. Great or than. Less than is and. Great or than. Less than is and. With absolute value. You have to have absolute value and this symbol for it to be an or an and problem. Okay, next. Okay, so I wrote all the possibilities so we can review this again. Absolute value with the equal sign, the conjunction is or. Absolute value with greater than or equal to. Both of these conjunctions are or. Absolute value with less than or equal to. Both of these conjunctions are and. I will tell you that you will not see the and word in most and problems. And I'll show you what I'm talking about in just one moment. Now, steps to solve absolute value inequalities. Get the absolute value alone, decide which conjunction you have, write the inequalities properly and solve, graph the solution on a number line, and write the solution in interval notation. And it says solve, graph, write final answers in interval notation. Okay, I want to go through these first few and talk about, you want this alone. It's okay on that one, it's alone. It's alone on this one. It is not alone here. So before I do number 3, I will have to get rid of that +4, and I'll highlight on the next slide as well. But let's go ahead and do these. Okay, so it says get the absolute value alone. Number 1, my absolute value is alone. Number 2, decide which conjunction you have, less than or equal to. So remember, I'm going to write it again. Less than or equal to, this is and. Greater than or equal to, and equals, these are or. So less than and. An and problem is written very specifically. Write down what's highlighted in red. Just write it down. On either side of what you have written down, write down this conjunction. So I highlighted that in blue. So I'm going to write down less than or equal to on the right and less than or equal to on the left. And then put positive 3, whoops, nope. Put positive 3 on the right, because it would be the biggest, and negative 3 on the left. Now we're going to solve that. We are going to get this alone. I want to get n alone. How do I get rid of dividing by 4? You multiply by 4. So I'm going to multiply each section of this problem, because I'm going to highlight and show you. There's 1, whoopsie. There's 1, 2, 3 sections. 1, 2, 3. So I have to multiply each section by 4. So negative 3 times 4 is negative 12. N divided by 4 times 4 is just n. So less than or equal to n. 3 times 4 less than or equal to 12. So now my absolute value is alone. This is an and problem. I'm going to show you the long way around. You do not have to draw this on your paper, but I'm going to show you the long way around. Before I wrote that and is the intersection. So I want to show you both of these. N, got to read this one backwards. N is greater than or equal to negative 12. So I'm going to put negative 12 on the number line. I'm going to put a solid circle greater than or equal to shade to the right. Then I'm going to draw another number line. And I'm going to graph this part. N is less than or equal to 12. So I'm going to put positive 12. And I'm going to put a solid circle. And I'm going to shade to the left. Now, and is the intersection of the shading of those two. So if I were able to pick up this number line and put it on top of the one above it, where would the blue and the red intersect? I think you can see if I do this little dotted lines. Can you see that they would intersect from negative 12 to 12? You can't include this part, and you can't include this part because it's not part of the intersection. So the shading would intersect from negative 12 to positive 12, and I want to do that in another color. And you're welcome to use other colors also. So positive 12 to negative 12. And I always say, you'll hear me say this, you and me go together. That's what your shading is going to look like. You and me go together. So that's the shading for an and graph. Now we're going to put this in interval notation. And again, I want to show you and remind you that we're reading this from left to right. And over here, which I don't know if I can write. Nope. Over here to the left is negative infinity. I can't reach all the way there. On the video, you can't see my little tools I have on the far left. And over here is positive infinity. So I'm looking at this black number line, reading it from left to right. Where does my black number line start being shaded? It starts at negative 12. I'm going to switch to black. It starts at negative 12 with a solid circle. And then where does it stop being shaded? It stops at positive 12 with a solid circle. That is my interval notation and my answer for number 1. Okay, now let's look at number 2. The absolute value of x divided by 6 is greater than or equal to 5. So I have absolute value with a greater than or equal to, that would fall here. So this is or. You do write down the word or. And you take what's in the absolute value out. Use the symbol greater than or equal to positive 5. Take what's in the absolute value out. You're going to put negative 5. And remember, when you multiply or divide by a negative, you flip the inequality symbol over. And now we're going to solve both of those. How do I get rid of dividing by 6? I multiply by 6. So x is going to be greater than or equal to 30. Or how do I get rid of dividing by 6? multiplied by 6. X is less than or equal to negative 30. Okay, now I want to show you how this one works. Or is the union. So I'm going to draw two number lines up here. You do not have to draw these, just please listen. X is greater than or equal to 30. So let me switch colors. So here's positive 30, solid circle greater than or equal to 30, and then X is less than or equal to negative 30. So negative 30 is down here, solid circle less than or equal to. And or is the union, which you just put these two together, and whatever's shaded on both of them go on your shading. So you can see you're going to include the red arrow and the blue arrow. So my shading starts at negative 30 and goes forever to the left, and then is also at positive 30 and goes forever to the right. And again, these number lines are really fancy. You do not have to write your number lines that way. Then we're going to read this number line from left to right, from left to right, from negative infinity to positive infinity. Where does this black number line start being shaded? It starts being shaded at negative infinity. Negative infinity gets a parenthesis. Where does it stop being shaded? So it starts here at negative infinity. It stops at negative 30 just for a moment. So I'm going to put comma, comma, negative 30, and negative 30 is solid, so you put a bracket. And then you've got all this, let me get my pointer. You got all this black number line, and then it starts being read again at 30. So when you're doing or, it's the union. So you put this weird symbol that looks like a U. It's not the letter U, it looks like a U. So union, it starts at positive 30. Where does it stop being shaded red? Positive infinity. So you put a comma, positive infinity, and then put a parenthesis. And so that's my answer. All the ands that we're going to do are going to look like number 1. All the ors that we're going to do are going to look like number 2. So just remember that. For our class, all the ands we're going to do look like number 1, and all the ors look like number 2. Okay. For the next one, I am going to get my absolute value alone first by subtracting 4. So the absolute value of n is less than 8. And now I'm going to decide my conjunction. Is it and or is it or? And when I look up here, I see it's that symbol. So you write down what's in the absolute value. You put that symbol on either side of it. You put positive 8 on the right, negative 8 on the left. And then if you need to, you get your variable alone. But is this variable alone? Yes, it is. So this is solved. I can't do anything else with it. And it's an and. So remember, you and me go together. So I'm going to plot on the number line negative 8. And it's an open circle because it's not equal to. And then I'm going to plot on the number line positive 8. And it's an open circle. And I'm going to shade everywhere in between. And now I'm going to read this number line from left to right, from negative infinity to positive infinity. Where does it start being shaded red? It starts at negative 8. Oops, I want to use black. It starts at negative 8 with an open circle, so you put a parenthesis, comma. So it starts here, and it goes all the way to here, and it stops. So I'm going to put positive 8 here, and it's an open circle, so you put a parenthesis. So that's my answer to number 3. Now on to 4 through. Now I am going to, let me see, highlight my absolute values. If this one's not alone, this one's not alone, this one's not alone, and this one's not alone. I'm going to save number 6 and number 7 for us to do together in class. So I'm going to do number 4 with you and number 5 with you, and then that'll be it. And I promise that I will remember that you did not have to do 6 and 7. If you want, you could go ahead and write in class together between 6 and 7, just so you'll remind yourself that we're not going to be doing that. Okay, I need to get absolute value alone, so I add 3. Absolute value of n minus 2 is greater than 8. So this one is alone, so I'm good to go there. Now let's decide on number 4 what my conjunction is. Remember, if you have greater than or equal to, then that conjunction is or. If you have less than or equal to, then that conjunction is and. So I have greater than, so my conjunction is or. Take what's in the absolute value out, greater than positive 8, or take what's in the absolute value out. You put negative 8, and you have to flip the inequality symbol. Now solve, get n alone, add 2 to both sides. N is greater than 10, or add 2 to both sides. N is less than negative 6. So remember, our OR problems all look the same when we are graphing for the ones that we're going to be doing. Greater than 10, I think this is 10, oops, and look, I was putting a solid circle. What's wrong with that? Greater than 10 gets an open circle, greater than 10, less than negative 6. So negative 6 gets an open circle, less than negative 6. Now we're going to read that number line from left to right. Where does that black number line start being shaded blue? Negative infinity. It stops at negative 6, and then it's black for a while, and then it starts again at 10. So this is the one that has a union in it. So it starts at negative infinity. It stops at 10 for a second, and 10 is an open circle, so you put a parenthesis. Union. Oh, it's not 10, it's negative 6. See, I was about to make a goofy mistake. Negative 6. Union, it starts at 10 again and goes to positive infinity. So that's my answer to number 4. Now number 5. First decide your conjunction. Less than is and. Less than is and. Okay, so for and problems, you take 10 plus 4x out of your absolute value. You put that less than symbol on either side. You put positive 14 and negative 14 because this is an and. And then you want to get x alone, so get rid of adding 10 first by subtracting 10. So negative 24 is less than 4x, which is less than 4. Then divide by 4 to get x alone. Negative 6 is less than x, which is less than 1. Okay, now we're going to put that on a number line. You and me go together. So negative 6, open circle, negative 6. Positive 1, open circle. You and me go together. And then I'm going to write my interval notation. Reading from left to right, it starts being blue at negative 6 with an open circle, and it stops being blue at 1 with an open circle. That's my answer for number 5. And like I said, we will do these in class together when we get there. So once you complete through number 5, scan all your pages, which should be 2, and then submit this assignment in Google Classroom. I hope you have a wonderful day. Thank you for watching.